Moving along, we've got set precision example. You're going to notice that the code here is the same as the formatting output. But what I wanted to draw your attention to was if we take a look here at for double number 1 and double number 2, the values here are different than they were last time, right? And if I run this, this is the, can I call it the alarming thing that you're going to want to be aware of, is the output here is logarithmic, and that is going to screw up the user who is looking at this, right? They are going to want to see, instead of an exponential notation here, they're going to want to see, what I would call, can I call it standard? Like Western American standard formatted output for numbers. Like, yo, I am looking for decimals. What is 2e plus 0, 1? So do be careful and do be aware, and, go back and look at what your output is. And, just this is a general reminder that when you see this kind of output and that's not what you're expecting, just remember that it's probably because either one of two things. Number one, you did not, in this case, it is not number one. Number one, you did not make an assignment when you did your declaration, so it did not have an initial value. So when C++ goes through and actually looks at that storage location, it's going to output the resultant of whatever is in the, the stack for where that was. So this is going to be an issue. That's not what's happening here. We do have a declaration and an assignment. So really what this means is, I haven't given it enough precision here. So that gives you a way of going back and recovering from what is, largely going to be seen by your user as an error, when really it's not an error, it's an error in precision.